Leg 5, right? This one will be the first one. The logic behind it is quite simple, but the it's quite tedious to do every single function because, like, I'm sure you guys have read, we have 8 member operator and 15 non-member operators. So, I mean, you just go through all this. What you're supposed to do is that you are supposed to make a class point that's able to do like math vector type of shit. We didn't. I mean, we guys all kind of learn vectors in secondary school, matrix and all that. This is basically what we are doing. So, we're just creating like a point class, like the point of like a point in the graph, the kind of thing. So, let me just go over. Okay, I will explain what member operator means. So, member operator, right, this is called operator overloading, which means that you just basically you assign an operator to the class. So when the class sees this operator, right, it knows exactly what to do. Like it doesn't perform normally like other stuff like double or in. If in you plus, you get the sum of the two ins, right? No, but this one you have to declare everything, like plus equals postfix, prefix, and prefix and postfix decrement. So Jeremy went through these two, so I won't go through. For these two, it's a bit confusing. I think this one is okay. Okay, this one is a bit confusing. Let me show you where it starts, where it's being used. Wait, oh wait, here. So it's being used over here. As you can see, it's using the assessor value, pointer 0 and pointer 1. And what we are expecting output from here, yeah. So if we assign pointer 1 to pointer 4, pointer 1 of we assigning 0 of pointer 1 and 1 of pointer 1, we're expecting it to be 3 and 4, right? If you expand this out, sorry, if you expand this pointer 0, we should get 3, and pointer 1 we should get 4. So if you look at the expected output, pointer 1 is 3 4. Shit. Is it too high or too low? Okay. If pointer 3 is 3 4, pointer 4 should be equals to 3 4 as well. So it's just a small example. We are expecting them to return a double so that it can store into a pointer. So we will make it return a double using this operator of size index, and then using this index, if index is equals to 0, we will return this x, and if it's equals to 1, we return this y. As you can see, if it equals to 0, we return x. If it's equals to 1, we return 4. So it's not like your simple. It's not an array. It's not a string. It's not a vector. It's just an assessor, right? It's just to assess the values of a pointer. Okay, don't need to think so hard about it. Minus plus plus, nothing much to do. This one I'm not so sure. You should not compile, but it compiles for me. I think I'm missing something. But I don't know how to check. Then the rest is C out. Okay, C out. Maybe this one I can explain also. So for this one, this is in the PDF is a non-member function. So the difference between member and non-member, right, is that a member is part of the class. Okay, they are the class, but the non-member class, they're just friends of the people inside the class. Like they just know people that belong in the class, so they are friends, you know. so they can enter the exclusive club. You can access all the private numbers, private data, right? You can declare this as member functions, but we are told to declare as non-member, so we'll do as non-member. Except I think for these two, right, operators, you cannot, some of these operators, right, you cannot declare it as member. Some of these you can only declare as friend functions. It's a syntax thing, I'm not so sure about that, you have to look it up. Quite easy to search. So okay, output writes to output stream. Makes sense, right? But how do we do that? It sounds so simple, but how do we do that? We will do that. First, we need to create friends, right? So these are our 15 friend functions. I haven't do one. I will do one with you guys later. I mean, we'll do this now. Later. It's called the dot product. I'll do it later. I'll go through this one first. So for the friend functions, we are looking at output stream. So you just declare this first, right? Friend output stream. This one I'm doing it all in one folder because this is just for testing. I'll later transfer it to the 3 separate folders. I mean 3 separate files. So in your class, this should be your HPP. You will declare this outside the inside the private. You declare the friend inside so that they can access the private functions. So friend std, always need your std operator. I mean std outstream, then your operator that you want to use. If it's like this, it's somewhat easier to see. If you're using this operator, okay. So you're trying to output an output stream, and then in that function, let's see how it works. Right? You see here, it's an output stream on the left side. It's an output stream on the left side, and then you're returning output stream. Right? You're returning the output stream. So on the left side, you have the output stream. On the right side, you have the pointer. Make sense? Left side, output stream, which is this. Right side, pointer. Make sense? I mean, output stream should be this, but this one is converted already. And then afterwards, yeah. So how do you do it? Very simple. Just like this. So you're returning output stream, right? So std output stream. Then you declare everything else, and it's just OS blah blah blah, return OS. That's it, very easy. Let me try to make it run it so I can prove it and teach you a new trick. I like all of this. Control slash. You just run a constructor test. I need to plan this now. I'm not sure. 156. Oh. Images. Prediction. What's this? Operator style. Okay, you know what? I don't want this. I'll take a look at it. What's going on? Am I in the right? Undefined reference to operator. Oh. What's doing it halfway? What's this? Oh, it's pointer. Dot pointer. This is dot product test. I told you don't have. Okay, I'll do that later with you guys. Alright, so managed to print everything out. So you can see that the CL is working exactly with this output. Right. You don't have to worry much about the formatting. for this one since you can't see the CL. Right, okay, in the terminal everything is here. Yeah, it's all printing properly. Begin exactly to the output dot text. Okay, so now let's do the dot product test together. So let's look at the PDF. What is dot product? Return double representing dot of scalar product of 2 point. I have no idea what this means. So what it wants is, it just wants a xy plus x2 y2. Okay, I think we can do that. So first thing first, let's look at the driver or the main function, and let's see what dot product wants from us. So let's uncomment this out. Right? And you notice just now before we got the arrows, right? I don't know whether you guys saw it. Okay. These arrows are very helpful so that we know what we're actually supposed to do. So you can see here that what is required from us is that we are expecting these two values, const and a normal HLP 2 point, and that's it. And then they're saying that there's no match for operator star for const and HLP 2 point and this one. So let's give them what they want. And comment this. So let's give them what they want. Let's first, in the friend function, we'll make a new friend for them. Okay? So now they have a new friend. And then let's describe the friend. So the friend is a dot product. Oops, that's the wrong button. It's a dot product. So what a dot product does is, okay, first are we returning double? No, we are returning. What are we returning? Guess we can return point. So let's not put this. Let's look at the PDF. What does the PDF say? The PDF say that we are returning double. Okay, then we return double. Right. Forget what dot product is. So in our prototype, right, we don't need to declare the variables, but when we're using, we have to. Otherwise, we're not able to manipulate anything. Okay, so we just create a new double. This is what we're going to return. Or we just do this. We're going to return this, so we just name it dot. Then dot will equals to, if you look back at the PDF, the equation for dot product, it's just x times y plus x times y all the way. Okay? So let's do that. X times y plus RHS x times dot y. Right? And this should give us our dot product. So this function, we're just going to return dot anyway. Why not we just return this, and then we can just remove 2 lines and make it simple. Right? Clean code. And forget to put and dot product test. Let's scroll up and see here. Okay, let's see our output whether it matches. But you guys can't really see. Okay, our 3 4 3 4 1 2 1 2 is 14, so that's wrong. It should be 11. So let's try to see what's the error. So you guys are now on my debugging. See how I debug. So maybe let's not do this. Or maybe we can just do this. Let's just see out and let's see what we get. I have a let's see what we get if we see out like that. What we should expect, right? What we should expect, okay, let's look at the output again, is 3 times 1, we get 3, 4 times 2, we get 8, 3 plus 8, we get 11, right? Makes sense. So we should be able to see that, and let's see what's wrong. Let's see what's wrong. What can't we get? So what we're actually doing, right, is we are taking 3 and 4 and 1 and 2. I should get 3 and 1 and 4 and 2. So it shouldn't be R. It shouldn't be Y. It should be R instead of X. And then let's change so that we can see. This STD print F is I'll print your error message so you can know what's going on. Okay. 3 8 11, nice. 6 3 22, nice. 3.3 8.8 12.1, nice. Is that what you're supposed to expect? And you're supposed to expect 11 22 12.1. 11 22 12.1. Perfect. See, easy, one function down. Now you just have to do 15 more, right? Yeah, but this how you're supposed to do it. So you guys get the gist of how you're supposed to do functions, member function, all that. I hope you guys will be able to do it by yourself. Nothing much to say. This one is a bit complicated, but formula is here. What it's basically doing, right, is you are rotating. Yeah, can you imagine, like, if there's a point in the graph and you're rotating it 90 degrees or 45 degrees, for your X and Y change, it will change. And how much does it change? You will have to refer to this formula, right? This formula. So your new X will become S cosine. Your new X will become S cosine theta minus Y sine theta. And theta meaning is radius. But when you see the output, we are given, let me see, rotate. Yeah, we are given degrees. So we need to convert our degrees into radians, right? Now you got radians, you can do the formula. So X times sine cosine radian theta times Y sine theta. Same thing is here. This is the formula basically. And then there's two different type of formulas. One, if theta is more than 0, I mean, what the direction, the degree that you are turning, the direction, is it clockwise or anti-clockwise? If you are turning it, if you are positive, means you are turning it anti-clockwise. If it's negative, means you are turning it anti-clockwise. The formula will change, because the X and Y will be totally different. And then, yeah, so these are the formula. Yeah, it has to be negative, unless you want more properly. Then that's it. Yeah, Then afterwards there's this epsilon. You guys know what epsilon means? Epsilon means that it's an arbitrary value, because if we are working with doubles in programming, you always know that if the value is too small, it will get rounded. It will get rounded in the direction. In this case, it will round down to minus 0.000. So let's say if we didn't have this, if we didn't do this, we can see it happen for x. We notice that our output here, right, is 0.000, right? But if we run the thing, without the epsilon, we get minus 0.0. It doesn't make sense. So let's put it back. Run the thing again, and then we should get minus 0.0. Right? Yeah. So that's it. That's all the tests I can do to make diff live, so we can see whether it checks out. .txt, and then to do diffs. It's a big fun. Diff. So let's diff. Oops. Let's diff output text with they are in different folders. This is output text. This is my output text. Alright, I'll do it differently. Let's make it your output text. And yeah, okay. Let's just copy this. Okay, so now we can diff. Here's my diff. Copy, paste, and oh shit. Why is it empty? Oh, input test. Okay, maybe I can go through input test. So input test, I remove it here. What input test means is that you will take an input, right, like user input. So it's our input test, right? We use you know how we use our SDDC in? We use these two arrows, yeah. So we will use that the same way, and then to input iStream. Yeah, we use iStream. Sorry, I point to the wrong arrow. We use std input stream. So over here, this is our friend function, and this is the definition of our friend. Input stream, input, then we just store whatever inside here. So let's see how it looks like now that everything is running. So the reason why I done it before, because you have to actually write your input. So let's base it on the output that they give us, and see whether we can get it, to prove that it's legit. So pointer 1 should be 3.4 and 7.5. 3.4, 7.5. Alright, enter. That's what we got. Enter XY pair, 1.2 and 2.3. Right, we got that. Now we enter 3 pairs all at once. -1, -5, -5, 6, -1, 5. And it all runs. Shit, I just skip. It's the input test. Right here. Okay, over here. You can see from here. -1, -5, everything is down, everything is perfect. Running exactly as it should. Right. I'm not sure if I can output it properly. Possible. Well, we can just, okay, never mind, we'll do another method. we'll put this onto Moodle. Moodle will be our lifesaver. Oh, don't see my password. Okay. Assignment 5. Lab 5. Oh, I never do the HPP. Shit, man. I need to do HPP first. Okay, HPP time. Because I haven't do this one, I'll show you guys how it looks like. I mean, if you guys want to go also can. I think I explained most of the part. Is this the right one? Shit, I didn't save. Anyway, yeah. So let's do our HPP and our CPP. So this is the one that I'm testing on, which is working fine. But as you can see, if you're coding a lot all in one file, right, it gets really disgustingly long. You just scroll down forever. So let's not do that. Let's make it nicer. Okay. So to put stuff into the pointer HPP, what you have to do, right? You just my namespace. Oh my god. Okay. Minimize. Okay. It's not inside the namespace. Not inside namespace. Okay. So what you do, right, is you take the class functions all the way here. Take it. You copy it. And you paste it here. Yeah, I guess we can just do it private. Paste it here, right? Then now you have to declare the non-friend functions. This is just the header stuff. Guess I can just use this. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're missing one. What are we missing? It's probably a dot pointer. Dot, not dot pointer. Friend. Same thing. Okay, we have everything. 1, 2. Check PDF. One rotation, 2 distance. Rotation, where's my rotation? Rotation. Okay. So. Right. Yeah. Okay. That's 50. PDF. Rotation, distance, translation, rotation, distance. Should be correct. Okay, there's our HPP and our point CPP. We can remove all these. And I don't think I need this. hours. I don't think we need this. Not sure. Oh wait, we need this, but we don't need the class. What we need to do now? Do we stay in the class? Let's try to compose the class. G++, C, SD, equals C++, no search for. No search for. Oh. Okay, now compose. Let's link it to our point track. Oh my god. You know this is fine. We should be driver's fault. Right. Okay. Let's edit the driver. Oh. Oh, this I'm going to up. Hit this. No, we should find it. Okay. Magic trick. Let's just run control to this. And the rest we can just comment on. What the fuck? You. Okay, what's wrong? Basic ocean. No match. They give you a friend and still no match. Let's do this. You declare outside. Non-member, non-friend. Oh. That's fine. Let's just copy this. No operator. Plus plus. This one. No match for operators. Let's I give you this. Not free member. What do I need to do? No. I don't understand. I'll fix this. Fix this, but you guys get the gist of it. Can maybe work on it yourself. I'll give you the other lab file first. Let me just stop.